All right, everyone, our homework last night, at least part of it, was worksheet number 1. The answers for worksheet number 1 are up on the board here right now. Take a look at them. Compare your answers with these answers. And in a moment, once you've had a chance to do that, we'll take a look at any of the questions that you need to go over. Whether you got them wrong or whether you got them right and you're just not quite sure exactly how you got them right. So we'll give you a couple minutes here right now just to take a look at that, and then we'll field your questions. All right, then let's take a look at questions 7 and 8, the questions that we need to go over here. Number 7 says, a 1 kilogram rock is thrown up into the air from ground level at a speed of 8.00 meters per second. The ball travels up to a maximum height, then returns to the ground. Calculate the rock's momentum as it strikes the ground. Now, some people had a little bit of trouble with this question. Some people didn't have trouble and did it one way. Some people didn't have trouble and did it a different way. So there's 3 groups of people out there today. The first way we're going to look at this is mathematically. And then we'll look at it logically and see that we get the same answer both ways, right? Let's circle some givens here. We got our mass here. We got our initial velocity is 8.00 up. Okay, a ball travels to a maximum height, then returns to the ground. We want to find the momentum as it strikes the ground, as it comes back down and hits the ground. So let's say we want to find PF is equal to m times VF. That's not unlike some of the questions we've already done. That's not the hard part. The hard part is, what's the final velocity? We all know what the initial velocity is. It's 8 meters per second when it's launched, when it's thrown up into the air. But what is it when it comes back down and hits the ground? It has to be the exact same. Logically, it has to be the exact same. Let's think about it this way. Look, if you've got a rock that starts at ground level at 8 meters per second and it goes up into the air, it slows down at a rate of 9.81 meters per second squared. Slows down, slows down, slows down, slows down, stops. So it decelerated or slowed down at 9.81 meters per second squared that entire way up until it stopped. And then it turns around and comes back down and speeds up at 9.81 meters per second squared for the same distance. Well, what speed is it going to be going after it speeds up at the same rate as it slowed down at? The same speed that it started at. So the final velocity, VF, will be, if we just think about it logically like that, VF will be 8.00 meters per second down, or negative 8 meters per second. Now, you don't like that logic? You have trouble coming up with that logic? Then let's do it mathematically. Let's say, like we have for a number of the other questions, VF squared is equal to VI squared plus 2AD. Let's analyze this entire trip. We don't know what VF is. Okay, we're pretending we don't know that it's -8 here right now. We do know what VI is. It starts at 8 meters per second. So we're going to say 8.0 squared plus 2 times negative 9.81, because as it goes up and down, it accelerates at negative 9.81 meters per second squared. What's the displacement over this entire trip? 0. It ends up where it started. So D is 0. 2 times 9.81 times 0 is 0. So we end up with VF is equal to the square root of 8 squared. What's the square root of 8 squared? 8. Square root of 8 squared is 8. That gives us the final speed. And of course, we want the final velocity. We can just say, oh, we know that it's downward, so we know that it's a negative value. So the mass is 1.00 kilograms. We multiply that by the velocity of negative 8 meters per second, and we get a momentum of negative 8.00 kilograms meters per second, or 8 downwards. Does that make sense? How many people got that? Okay, how many people did it the logic way? Okay, and how many people did it the mathematical way? Okay, about half and half. So either way is good. Okay, they're all good. I wouldn't say that one way is better than the other, but they both work. All right, let's take a look at number 8 now. This one says a 1.5 kilogram rock is thrown up into the air from ground level. We don't know what its initial velocity is this time. It reaches a max height of 7 meters, and then it returns to the ground. Calculate the rock's momentum as it strikes the ground. Okay, let's once again say this is the mass. let's say this is our max height. Oops. We want to find the momentum as it strikes the ground. We want to find PF again. We know once again, as it has been for a number of questions, that PF is equal to M times VF, but we don't know what VF is. And we can't do this exactly the same way as we did the last question because we also don't know what VI is. Now, I know that some people are looking at this and saying, oh, okay, well, we'll just go to the VF squared thing again. VF squared is equal to VI squared plus 2AD. And then they looked at this and said, but we don't know what VI is. We don't know what VF or VI is. We know that A is negative 9.81 and the displacement is ultimately 0, but we don't know what VI or VF is. So that doesn't seem to help. Here's what I want to do. Okay, if I can't do this the way we've done, the exact same ways we've done the rest of the questions, then I want to look at part of this problem. Let's look at just the trip down. As this rock is thrown up into the air, it slows down, it slows down, it slows down, it slows down, and it stops when it reaches the top. And then it speeds up and speeds up and speeds up and speeds up and reaches a final speed down here. If I analyze just the trip down, then I know what the initial velocity is. How fast is it moving when it starts the trip down? 0. So we're analyzing only the trip down. That makes delta D not 0. Okay, delta D for the entire trip is 0. Delta D for just the trip down is what? Not 7, but you're close. Negative 7. So now we're going to say VF is the square root of all that, which gives us what? Does anybody have that? 11.71. 11.71921 meters per second. That's the final speed. Now, technically, the final velocity is negative that, right? Negative 11.71921. And we do the math there, and we get the answer that I gave you a minute ago, which was 17.6 downward. So we see a question like number 8, and we try the PF. The PF is equal to M times VF, and we realize we don't have V. So we try to find V like we have before. Okay, and we realize, oh, VF squared is equal to VI squared plus 2AD. Doesn't work, at least not in exactly the same way as it has for the other questions, where we analyze an entire trip. So what do? Well, we don't panic. Okay, we don't panic. We just start thinking, okay, well, what else can I try? Is it okay to analyze part of a trip? Sure, if you have data for part of the trip. You can't just randomly do something, but if it's logical, then why not? Just start trying things. If you're not sure what to do at that point where you don't know what VI is for the entire trip, just start trying things, as long as it's logical and valid. Right? Is that okay? All right, let's take a quick review of that variable value changing stuff that we did yesterday, and then we'll check the homework that we had on that as well. Remember that we said variable value changing was a technique that we use to solve for something after the variables that have affected it have been modified. So for instance, we've got a momentum of an object of 10 kilograms meters per second. We double the mass and we triple the velocity. What does the momentum become? Before yesterday, we couldn't have answered that question because we didn't know what the mass was to triple. We didn't know what the velocity was to quadruple or whatever it was. But yesterday we learned a technique to deal with that. And we called it variable value changing. Let's say that we did have a momentum of 10 kilograms meters per second. And let's say that we did triple the mass and we did quadruple the velocity. What would the new momentum become? Well, my original momentum, we'll call it PO, is equal to the equation for momentum, M times V, like it always is, but in this case, it's also equal to 10, right? That original momentum, 10 kilograms meters per second. My new momentum is not m times v anymore. I told you guys yesterday. Look, the equation for momentum is technically not mv. Okay, we just represent it that way. The equation for momentum is technically mass times velocity. Well, it still is. That hasn't changed. We're just not going to represent mass by m anymore, and we're not going to represent velocity by v. We're going to represent mass by 3m, because in this question, we tripled the mass. It's 3 times what it was. It's still mass, but it's 3 times whatever the value of m was. The velocity, we said, was 4 times the value of whatever v was. We can pull those numbers out in front. 3 times 4 is 12 times mv. What's the value of mv? That's what we wrote down in the beginning. mv is 10. So it becomes 12 times 10, which is 120 kilograms meters per second. Does that ring a bell? All right, we had 2 questions for homework on that last night. Those questions were on 452. Any issue with either of those questions on 452? Remember, of course, that question number 1, the answer for it was wrong in the book. I think it was 3.09, wasn't it? Yes? Number 2? Yeah, we can do both of them if we need to, guys. Yep, okay. So we'll do number 1 and 2. 1 says many modern rifles use bullets that have less mass and reach higher speeds than bullets for older rifles, resulting in increased accuracy over longer distances. The momentum of a bullet initially is 8.25 to the west. What's the momentum if the speed of the bullet increases by a factor of 3 halves, or 1.5, and it decreases by a factor of 3/4? We mentioned this yesterday as well. If it's decreasing by a factor of 3/4, then its new value is not 3/4 of what it was. It's 1/4 of what it was. So I'm going to write down a little note there to remind me of that, okay? When I go to solve this, I'm not going to plug in 3/4 m. I'm going to plug in 1/4 m. Right? We don't care about what it's gone down by. We care what it is. Momentum is not what the mass has gone down by. The momentum is related to what's left of the mass. So my original momentum here, is m times v, of course, and it's equal to 8.25 to the west. My new momentum, well, the mass decreased by 3/4, so now it's 1/4 of what it was. The velocity is 3 halves of what it was. We can pull those numbers out in front. 1/4 times 3 halves is 3/8. Does that make sense what I just did? Just multiplied those 2 fractions together. 1/4 times 3 halves, 3/8 times mv. And we know the value of mv. It's 8.25. So it's 3/8 times 8.25. And when I do that math, I end up getting 3.09. Jesse? No, it's increased by a factor of 3 halves. So it's not what it was plus 1.5. Okay, it's what it was times 1.5. Does that make sense? Okay. How many people got that? Okay, good. Not bad. And number 2 says during one part of the liftoff of a model rocket, its momentum increases by a factor of 4, while its mass is halved. The velocity is initially 8.5. What's the final velocity? This time we're going to use the same equation, p is equal to m times v, but we're going to rearrange it to solve for v, because we want to find the effect on velocity after we've changed this and that. So it's going to be v is equal to p over m. My original velocity is p over m. The original velocity is also 8.5 meters per second up. What does my new velocity become? Well, it's still momentum over mass, but momentum is no longer P. What is it now? It's 4P. And the mass is no longer M. What's the mass? It's 1/2 M. What's 4 divided by 1/2? 8, right? 4 divided by 1/2 is the same as 4 times 2 over 1, right? Multiplied by the reciprocal. So it becomes 8 times P over M. And we know the value of P over M. It's 8.5. So it's 8 times 8.5, which I think gives us 68 meters per second up. How many people got that one? A little bit less, eh? Those of you who had a little bit of trouble with that one, what was the problem? Was it recognizing that we had to rearrange it? I mean, we can rearrange it, right? We can all rearrange that, but was it recognizing that we had to rearrange it? Or was it the dividing by 1/2? Is that the issue? 4 by 1/2, okay, so you got 2 times 8.5. How many people got 17 for an answer? Okay, a couple people. Is it good now? Good enough that we can have ourselves a little quiz on Tuesday on momentum, including variable value changing? Oh, yes, you'll be fine with that. Yeah. Yeah, no, they did it wrong. Yeah, exactly as I remember if you heard me yesterday explain that, yeah. It's wrong because it's the new mass is not 3/4 of what it was. The new mass is 1/4. So they've written it one way. I don't know which way they intended it, to be honest. But the way that it's written, it's wrong. They did it wrong the way that it's written. Whether they intended it to be, this to be the answer. Maybe they very well intended it to be 3/4 of what it was and just worded it wrong. Or maybe they just solved it wrong. I'm not sure. But we're going to solve it the way that it's written. How would it be written? How would question number 1 be written if the answer was 9.28? You could say if the mass decreased by a factor of 1/4. Or it could say the final mass ends up being 3/4 of what the original mass was. Both of those would give us the same answer that they gave us, but that's not the way it's written. No, we wouldn't say increase. We'd say it remained 3/4 of what it was, or decreased to 3/4 of what it was. Yeah, does that make sense? If it decreased to 3/4 of what it was, well, if my money decreased to 3/4 of what it was, then I would have 75 cents left. If it decreased by 3/4, then I only have 1/4 left. Make sense? I've got $1. Okay? $1 to my entire name. If I decrease that by 3/4, then I've only got 1/4 left. I've only got 25 cents left. But if I decrease it to 3/4, then I'm decreasing it to 75 cents. Okay. By the way, I don't really just have $1. I've got almost 5. All right. I'm going to give you a little bit of time to work on page 453 here. With number 1 to 2, 5, 9, 11,